Alright, this is a video about Lab 3, and I'm not going to talk about those how to build a data or about those the commands like mirror feature, and I'm gonna focus on the swept and how to make the trigger part of our project. And so first, let's start with what you're gonna get. So you're gonna get the IGS file. So for um, for a better measuring on the IGS file, we use the drafting application. So the drafting application is gonna be well, first we need to have a model, a blank modeling file. So you want to create a new model file and save to some folder you have access. Okay, so let's say just an example. Okay, all right. So maybe trigger. Oh, but this is for measurement, so you can just keep this file name. Then we click OK. So now we have a blank model file, and what's different from last week is we needed to import the IGS file instead of opening the IGS file. So this way, because IGS file only have surface and curve, and we want the model to be a solid body. That way, you can get very clean cross-section view in the drafting application. So the way you convert IGS file to a solid body, you can only done it's only can be done by import IGS file. So first you need a blank modeling file. And second, we import IGS file. Okay, so now we click the import from IGS file, and now you want to define you want to find the IGS file you downloaded. So you should go to your folder to find that file. So let's see, that's a trigger here. Alright, then just click OK. Now next step is we want NX to merge or convert the surface in IGS file to solid body. So you want to make sure you click this, you check this option, automatic showing of surface. So this way it's gonna convert the surfaces to a solid body. And pay attention to this tolerance. You want this to be 0.004. It's the maximum tolerance NX has. So if you have very small tolerance, probably some surface is not gonna be sealed together. Okay, so as big as possible, that's gonna be 0.004. Then we click OK. Now it's gonna process a little bit. Okay, now, so you look at this model, you can see only one body here. If you open the IGS file, every surface of this model gonna be one body. So you will have a lot of bodies here, and they are all surface. But now we have a solid here. To verify this, you can select the filter to solid body, and you click this one. So that gives you a solid body. Okay. So now we have converted IGS file to solid body, and the next thing is we're gonna measure this model, so you can recreate by yourself. And well, we can have some analysis first. So you look at this shape, okay, you will think it's hard to extrude because you see here it's flatter and then this one is like a straight. So there's no way you can straight just by extrude you can't make it. You can't make this. And well, it's a very long piece, and you can see it actually goes along this ridge. Okay, and you have multiple different cross sections. Right, you can have this one. You have this one is like a triangular, and the bottom is like almost like a rectangular. And obviously the head is like is just rectangular. So we can, based on these features, you want to use a swept. Okay, so that's your swept tool, and it's about modeling. So once you decided that you go for the swept, now you want to know the dimensions of those cross sections. So that's how the drafting application will help you. You know, take cross section here and there, then you can measure the dimension. All right, so how we get into the drafting application? You click Start, and here is your drafting application. So once you click this, okay, it's gonna ask you what size of your sheet, aka paper. Okay, that's gonna be a mechanical drawing. So we're gonna convert a 3D solid model to your conventional mechanical drawing, and you can use templates. So the template is gonna have Siemens header and footer, and we just use standard size. So that's a blank paper. Okay, then make sure the unit is inch, and there's two ways you can create, you know, top view, left view, right view. You can choose wizard or you can choose basic view. Okay, personally I like base view command. Then you just click OK. And then we have a sheet here, and now I'm in base view, this command, and you have your model here. You can drop this, okay, and you can either choose the which view you're looking at. So also if you feel too small, then that's your scale, like 4:1. Okay, and once you click on the sheet, you will be able to pull out, you know, different views. So that was you know, let's say this is front view, then that's gonna be your left view, that's gonna be your top view, that's gonna be your bottom view. Alright, so based on our shape, you really only need this one view, but I can drop another one just by clicking here. Alright, you can keep doing that, and if you're done, you just click close. So now we are in drafting application. You can see the menus are totally different. And if you want, if something happens, the dialog box didn't show up, and you want to drop some new views, that's the first thing. That's the first option. Is create view creation wizard, and I just choose that one. I chose base view, so this one is like I just did. And you can also use this create view wizard. Okay, so that will give you a step by step. You can choose options, orientation. Orientation is gonna be the orientation of your parent view. That means, so this one is your parent view because you see all the other views come from this view. You can change it. Okay, and that's the layout. let's see, we have 3 views here. You can click this, you're gonna disable one view, okay, and then you can click either one. If you want disable, just click it again. Okay, now my computer is slowing down. Okay, back to the drawing we have. We have this view and that view. Okay, so if you want to measure all the cross sections, you want to make multiple cuts. Like in your mechanical drawing, you want to have all the section views. So if you want to create section view, that's a command. You click this command. Okay. First, you pick the parent view. So if you see those boxes, that's one view, that's another view, right? So we click within this box. So now you just picking up this view, and you can see the menu just expand. All right, now for this, the hinge line, you can just simply click here. Let's say we want a cuts here. Click here, and you can go up. You can pull to the left or right. Okay, let's just drop this one here. That's your that's AA section. And if we want to do another one, and probably sometimes you have parts that's um, not horizontal or not vertical. What if your cross section is a tilted cross section? So we can have this one. We can use this define hinge line. Okay, and here you can choose a method that's going to be 2 points. 2 points and define hinge line. So here you can select you can define the hinge line by select 2 points. First point, alright. So if I want a tilted one, I can do like this. So now this line is perpendicular and parallel to that 2 points I just clicked. So you can pull them out, maybe like here. First you have to drop this line first. Okay, we can drop this line here and you can pull this out. So that will give you a tilted cross section. Let me close this and undo this second. Alright, so we have a cross section here, and you can see the cross hatch. Excuse me. So that's why we need to convert IGS file to solid, because you get once you get solid body, you can have those cross hatch line indicating this is your cuts. Also, if you just open IGS file and you go to drafting application, the cross section is gonna be cutting on the surface. So sometimes there'll be a mess, and sometimes if you get rid of this background here, sometimes the cuts on the surface will not even show up. So the key point is you convert IGS to solid, then you come here, you can make clean cuts. Alright, so how we get rid of the background? Now there's an option here. That's our cross-section view. You right-click on this view. There's an option called Style. So we go to Style menu, and there's a tab is Section. Okay. So you just uncheck this background, and let's see. So click Apply. That is a very clean cut without the background. Okay. Then just click OK. So this way you have very clean cross section. That's easy to measure. So now we need to drop all the dimensions on this mechanical drawing. Since this part has a lot of fraction dimensions, we want the annotation to be fraction also. Now, how to set your dimension to fraction only? And we go to Preference, Annotation. Okay. Then first we go to Units part, the Units tab. So here, if you look at here, there's an option called like linear format. We can choose this fraction. Okay. And also somebody, a lot of people don't like the comma. You can change here. And that's one. The second one is we go to Dimension tab. Dimension tab, we have the position and tolerance. And some of the dimensions are like 1/32. So we want the precision to be pretty high. It's going to be 1/64. Okay. Then we're done. Just click OK. So now all the dimension you drop is going to be in fraction. So how we drop the dimensions, we're going to use infer dimension, just like in Sketch. Okay. We click this, and you can actually modify your precision here. So one thing to keep in mind is this is actually from a 3D 3D part. So although we hide the background, but actually in the model it's still there. So if you hover the mouse here, you'll see it's picking up the spline, and that's not. And this one is actually an arc. So to pick the right one you want, you just hover a little bit, and when you see the little dots, click on here, and you want to pick your arc from the quick pick menu. So that's the dimension of your arc. Okay, and maybe look at here, that's going to be the thickness of this sheet metal, and we just click on this line, and it's picking up the spline again. So hopefully, yeah, okay, that give us the thickness of the sheet metal. Okay, and probably you want maybe measure from here to here, or you can measure the length of this. Okay, so we can measure the width of the whole cross section. I click this point, and we click that point. Click the arc. Right? So that's gonna be the width from this to the center of the arc. Is that right? Yeah, to the center of the arc. And that's the same thickness. Okay. So you can calculate a little bit, and you can get the dimension. Also, we can get the height of this cross section. Okay, so you have height, width, thickness, and the radius of this arc. Okay, now we have one cross section. Then you can do another cross section, and apparently you can see from here that's your coordinate system. So when you model this part, you can start from this coordinate system, and so just keep measuring this cuts is obviously from IGS file, so it will automatically cut the surface. So this will indicate I create this model by swept, and that's one cross section. And apparently you need one at the origin, and that's another cross section, and that's the end cross section. So probably I have another one here. Okay, now you can keep doing cuts and measure all the dimension you need. And I'm gonna talk about the swept command. Let's close this first, and I'm gonna open the parts. And it's gonna be this one. Okay. All right. So we have this. I'm gonna show you how this was created. Okay. So let's show everything first. Show. Okay. How this was created was okay. Look at the blue lines. Those are the cross-section line for this part. Okay. So apparently I have multiple datums, and you can look into the slides how to build a datum at distance from the coordinate system. We have 1, 2, 3, 4, 5 cross section, and the one at the end. Okay, if you look at from the top, this datum is actually not parallel to your coordinate system, and this one is on curve. So when you create a datum, you can create this as on curve. So this surface is gonna be perpendicular, be normal to this curve. Okay, and so that's how you create a multiple cuts, multiple cross section, and once you get all the dimension from that IGS file, you can draw those cross sections. So if you can see 1, 2, 3, and that's the one we just measured. Okay, so once you draw those cross sections, and you want to use swept command. So swept is, if you look at here, it consists of two parts. The first is the section, so that's your cross section surface, cross section curves, and the second one is the guide. The guide is gonna be this ridge here. Okay, so optimally you want your cross section to be perpendicular to your guide curve, but since it's not very far off here, so it's fine. And alright, let's go ahead, and we can hide this swept. I'll give you a cleaner view, and let's hide those data first. You pick this filter and pick everything. I'm gonna pick all the data. Then you can right click here, and that's your shortcut menu. Excuse me. And hide this too. Alright, so when you're done measuring and let's say the sketch, this will be what you get. Okay. Okay, now let's start swept. So we have we just click this button, and you can do you can select the cross section. So when you select a cross section, the way swept works is it scans the cross section from one to the other and along this guideline. So the shape gonna match each other. So you have one little curve on the top. This shape is gonna scan to the next one. It's gonna be that curve, and this one goes to that cross section. Gonna be this top. So then you have a surface that goes, turns around. So well, let's select a cross section first. Now each cross section has a orange. If you look at here, orange. Okay, we click this one, and you see the arrow here. That indicates this top curve is your orange, and the direction is counterclockwise. And alright, so you can switch the direction, like click this, that's gonna be clockwise. Okay, and you want to make sure all the sections have the same directions. And you want to add another section. You want first click add new set. So each set here is one cross section. You don't want to mix two cross sections into one set. So let's click add new set, and then we click. So every time you want to click add similar spot, because the point you click is gonna be your orange. Okay, so you see the top curve. Okay, then the next cross section, add new set, and click add similar spots. Okay, then that one, since that's actually the thickness side of your sheet metal, so we want this curve to match this one. So we can add a new set first, then click this curve, and if you look at here, that's a wrong direction, or another direction, and also a wrong curve. Okay, so we pick another orange. Now it looks good. And so after this, all things goes back to the top. We select again the top curve, different direction, and go back to the orange. Okay, so make sure that you have the same directions. And the last section. Okay, now we have all these sections selected. Then we want to define the guidelines. So here we only have one guideline, and you can have 3 maximum. And how did I draw these guidelines? Well, for simplicity, I just draw this as an arc. So once you want an arc to be touching all the sketch you have. So how I did this is I drew a first cross section and second cross section, also the third cross section. And when I measure the parts, I also measure the distance of this point and that point away from the center of this hole. So the section 5 and the section 3 actually a little bit closer to the center compared to this point. And once you have this 3 cross section, you draw an arc which on a plane that perpendicular to all these cross sections. So the circle and this guideline is on another datum plane. And when you draw this arc, you want this arc to be tangent on this 1, 2, 3. No, not tangent. You want to define this arc by 3 points. 1, 2, 3. Okay. So once you define these 3 points, and you can have you define this arc, and afterward you just expand this arc, and based on this arc you can draw the other cross sections and make sure they touch at this point. But it's not necessary, like this one, you don't really need to touch each other, because so it's better you have a guideline that touching your cross sections or at similar spots like here, but it's okay you have them away from the cross section a little bit. Alright, let's pick the guideline. This is your guideline. Okay, so if you see this, it's already have some shapes coming out, and obviously you have some twisted shape, and because look here, you want the thickness go to this thickness, but it actually the bottom point of this goes to the point of that. So there's option you can modify this. So here is your section options. Okay, we want to pay attention to this one, linear and cubic. So if you pay attention to this curve here, cubic give you smooth transition between the sections. If you pick linear, that's going to be a straightforward, that's a straight sudden transition between your cross sections. Okay, so you can play with this, and for this application we need cubic. The second one is the alignment. As I said before, this curve here does not align to this curve, and I want to manually align them. You can choose by point. Okay, so now here you can drag those points. You can move those points around, and you want this thickness go here. That's right. And here, that's right. So that's right too. So it looks like when you use by points, sometimes it will automatically give you a better results. But again, you want to make sure this point, you can hover here and you look at this point, which point goes, which points on the other cross section match with this one. Okay, so if you look at here, like here, these 2 points, right, should be match these 2 points. They do match, but the point is the 2 points are symmetrical with the center line, and here it's not symmetrical. So you want to move this to the center, make them at 1 point, so that way the whole piece is symmetric to each other. And this way, but so here you want also make sure maybe you can put them in the center, or you can put them like symmetrical to each other. This really doesn't matter, okay, as long as you have a nice shape. And so if you look at the back, this point, okay, this point, that's the point on guideline, so it's not a point on the cross section. So you have one here, it's on the end of your arc. Okay, that one is on the end of your arc. So this arc transition to transits to this straight line. So that's the name swept. Okay, then we can come back and look. So for now on, if it feels like the scan or the swept is reasonable, and we can just do OK to finish this. And if you look at the shape here, okay, so you got the trigger, and as to the bottom here, you want to use this edge blend, because you can do you can draw a circle here and extrude a sheet body into this solid. Then you do a boolean subtract. You can cut away. You can use trim body. You can use a surface to trim away this, but it's hard to make sure the top surface to be continuously. Yeah. So let me just show you the edge blend. We use edge blend. Okay. So it's like your fillet command in Sketch. Okay. Just this one is on 3D. Now we first pick the edge. So we want to blend this edge. and the one at the bottom. So you can adjust the radius to make this one looks nicer, and make sure you don't cross section. Yeah, don't overlap this. Okay, and this will give you a similar shape to the one the IGS model. Also, you can choose this one. So you have circular. If you look at this picture, the blue lines, that's your curvature. So you from straight line to your circle is a sudden change in curvature. And if you want to use this one is actually a well, let's say it's a better looking up, smoother surface. Okay, so you have two parameters. You can change this one and also that one. So that's not arc anymore, but this one can give you a smoother surface, but it really doesn't matter, okay, for our application. So either one is okay. Then let's click OK. Now you have the trigger, and for this hole, you know what to do. Just do extrude and use this Boolean method. Okay, I'll show you. Extrude, and you pick this curve. Okay, and you want to do a symmetry. It's too much. Symmetric. You can either leave this blank, so that's your Boolean option. Okay, you can do subtract, and let's have a review. So subtract is gonna do this, right? And you can also use unite. Unite is gonna combine these two solid together. So or you can leave this blank. Okay, then you can use an individual command, a Boolean command here. Subtract. Okay, subtract. Sorry. So target body is gonna be this. Tool is the one you're gonna use to cut. Okay, then you click OK. So here we have the trigger already made. Okay, so here we go. Thank you very much, and I'm gonna upload another video about how to build the handles. So we can use swept for the handles. Also, we can use extrude for handles. Okay, thank you very much.